going down. Imagine the moment when the light runs out. You have been underground for perhaps an hour, moving through a passage that has grown steadily narrower, the rock pressing closer on either side, the ceiling dropping until you are crouching, until you are moving carefully with one hand trailing the wall. And then, on some instinct, or perhaps at the suggestion of someone who has been here before, you turn off your lamp. The darkness that falls is unlike any darkness you have experienced above ground. At night, above ground, there is always some ambient light. The glow of distant cities on the horizon, the faint luminescence of the stars, the moon, the sky itself. Even on the darkest night, in the most remote place, your eyes will adjust over time and shapes will begin to emerge from the dark. Not here. Here there is nothing to adjust to. The darkness is absolute and total, and it does not matter how long you wait or how wide you open your eyes. There is simply no light, none at all. The distinction between eyes open and eyes closed is meaningless for the first time in your life. And in that complete darkness, something interesting happens to the other senses. They sharpen. They fill the space that sight has vacated. The sound of water, dripping somewhere in the darkness ahead of you with a metronomic regularity that suggests it has been dripping at exactly that pace for centuries, comes through with extraordinary clarity. The smell of the cave, minerals and damp stone, and something ancient and cool becomes vivid in a way it wasn't when you could see. The temperature, a constant and uncanny cool that has nothing to do with the season above ground, settles on your skin with a quality of permanence. And the silence, not the relative silence of a quiet room or a still night. Real silence, the silence of a place where no wind has ever blown and no weather has ever reached. The silence of stone that has not moved, not in any meaningful sense, for millions of years. Caves are among the most ancient and least explored environments on Earth. Some of them have been forming for tens of millions of years. Some contain pockets of air that have not circulated with the outside world in centuries. Some harbor life found nowhere else, species that have been evolving in complete isolation for so long that they have become entirely new kinds of things, carrying the memory of the surface world only in their DNA, no longer in any organ or behavior or need. Tonight we are going underground, into the science of how caves form and how long they take and what extraordinary structures they build in the dark. Into the life that has found ways to survive where there is no light and almost no food. Into what caves have preserved from the deep past, including some of the most significant things our own species has ever made. And into the power that these underground spaces have held over the human imagination in every culture and every era from the very beginning. So let yourself settle, let your breathing slow, and let the darkness be something comfortable tonight rather than something to resist. How caves form. Most of the world's great cave systems form through the same slow, patient process. Water and rock, working together over geological timescales so vast that the human mind struggles to truly comprehend them. Rain falls. As it passes through the atmosphere, it absorbs carbon dioxide from the air, forming a weak carbonic acid. This is not a dramatic chemical transformation. The resulting solution is only slightly acidic, far less so than lemon juice or vinegar. But chemistry does not need to be dramatic to be transformative. It only needs time, and in geology, time is always available. This slightly acidic water percolates down through the soil, absorbing more carbon dioxide from the decomposing organic matter it encounters, becoming incrementally more acidic as it goes. And when it reaches limestone, something begins to happen. Limestone is a sedimentary rock composed primarily of calcium carbonate, the same material that makes up seashells and the bones of animals. It is hard and solid, and it looks, to the casual eye, as permanent and immovable as anything in the natural world. But it is soluble in weak acid, not quickly, not dramatically, but reliably and over sufficient time definitively. The acidic water finds cracks in the limestone, hairline fractures left by the settling of the rock over millions of years, tiny discontinuities in the crystal structure, spaces where two layers of stone meet imperfectly. It enters these cracks and it begins, molecule by molecule, to dissolve the rock. Over thousands of years, the cracks widen. They connect to other cracks. The water begins to move through the rock in channels rather than seeping uniformly, and moving water dissolves rock faster than still water, so the channels widen faster. Underground rivers form, carving passages through solid rock with the same patient authority that surface rivers carve valleys. And eventually, over timescales of hundreds of thousands to millions of years, vast underground chambers open in the darkness. Chambers that no light has ever touched, that no living thing has ever visited, that simply exist in the dark, growing imperceptibly larger, year by silent year, waiting. The world's great cave systems give some sense of what this process can produce over sufficient time. The Mammoth Cave System in Kentucky, the longest known cave system on Earth, extends for more than 650 kilometers of mapped passages, and new passages are still being discovered. Carlsbad Caverns in New Mexico contains chambers large enough to fit several city blocks comfortably inside them. The Waitomo Caves of New Zealand have been forming for 30 million years. And Sun Dung Cave in Vietnam, only fully explored for the first time in 2009 by a team from the British Cave Research Association, is large enough to contain its own weather. Its largest passage is 200 meters wide and 250 meters tall. In the sections where the ceiling has collapsed, daylight falls in and miniature jungles have grown up on the cave floor, with trees 30 meters tall, fed by the sunlight falling through holes in the ceiling hundreds of meters above. Inside Sun Dung, clouds form, actual clouds, drifting through the cave passage. It is not metaphor, it is meteorology. Formations. Inside caves, the same water chemistry that creates the cave also begins, over time, to decorate it. Water seeping through the ceiling carries dissolved calcium carbonate. When a drop of water hangs at the ceiling before falling, it is in contact with the cave air, which has less carbon dioxide than the water it came from. Carbon dioxide escapes from the drop, and as it does, a tiny amount of calcium carbonate is deposited. One drop, one microscopic deposit. The drop falls, another forms, another deposit. Over 100 years, this process builds perhaps 1 centimeter of calcite. Over 1,000 years, 10 centimeters. Over 100,000 years, a stalactite a meter long hangs from the cave ceiling, formed entirely from the accumulated deposits of individual water drops, each one leaving behind a fraction of what it carried. The corresponding deposit on the floor below, built upward by the impact of the falling drops, is the stalagmite. When the two meet, after a process that may take hundreds of thousands of years, they form a column, a solid pillar of stone, connecting ceiling to floor, built entirely by water one molecule at a time. Beyond stalactites and stalagmites, The variety of cave formations is extraordinary. Flowstone covers cave floors and walls in smooth, rippling sheets of calcite like frozen waterfalls. Cave pearls form in shallow pools, perfect spheres of calcium carbonate built up around a single grain of sand, polished smooth by the gentle circulation of water over centuries. Helictites grow in impossible directions, twisting and branching sideways and even upward, apparently defying gravity. Their form determined by factors in the crystal structure of the calcite that are still not fully understood. Moon milk, a soft white pasty coating of crystalline calcium carbonate, grows on cave walls in some systems like a biological growth, though it is entirely mineral in origin. A cave is not merely a hole in the ground. It is a sculpture of extraordinary complexity and beauty, being worked on continuously by water and chemistry and time, with no artist directing it and no audience to appreciate it. The formations exist in the dark for their own reasons, or for no reason at all, depending on your philosophy. They have been growing in complete darkness for longer than our species has existed. Life in the dark. The question of how life survives in a cave beyond the reach of all light is one that leads quickly to some of the most remarkable biology on Earth. Almost all life on the surface of the planet is ultimately powered by sunlight. Plants capture light energy through photosynthesis and use it to build sugars from carbon dioxide and water. Animals eat plants or eat animals that ate plants, and so the sun's energy flows through every food web on Earth, from the grass on the plains to the lion that eats the zebra that ate the grass. Remove the sunlight and the whole edifice collapses. In a cave beyond the twilight zone, the zone near the entrance where some daylight still penetrates, there is no sunlight. Photosynthesis is impossible. And yet caves are not lifeless. They support ecosystems of sometimes surprising complexity. The question is simply where the energy comes from. And the answers that evolution has found are various and, in some cases, genuinely startling. The simplest cave ecosystems are powered by organic material imported from outside. Bat guano is the most significant of these. Many caves host colonies of bats, sometimes numbering in the millions, that roost in the cave entrance during the day and fly out at night to feed on insects in the world above. What they bring back, in the form of droppings, is a rich organic resource that supports communities of beetles, mites, flies, springtails, fungi, and bacteria throughout the cave system. A cave with a large bat colony is effectively being fertilized by the outside world every night, and life can proliferate accordingly. But the most extraordinary cave ecosystems have found a fundamentally different solution. In 1986, a Romanian engineer was drilling in a field near the Black Sea when his drill broke through into a previously unknown cave. Divers who explored the resulting opening discovered a passage that led to an underground chamber that had been completely sealed from the outside world, with no connection to the surface atmosphere, for approximately 5 million years. The water and air inside the chamber were toxic by surface standards, rich in hydrogen sulfide, which gives rotten eggs their characteristic smell and is lethal to most surface organisms at high concentrations. Almost devoid of oxygen, a hostile environment by any measure. And yet the chamber was teeming with life. 48 species were eventually identified, 33 of them found nowhere else on Earth. Unique species of water scorpion, leech, isopod, and spider, all pale and eyeless, all adapted over millions of years to conditions that would kill a surface organism in minutes. At the base of the food chain were bacteria, but not bacteria using photosynthesis. Bacteria using chemosynthesis, a process that extracts energy from the chemical reactions between hydrogen sulfide and oxygen, in a way that has nothing to do with sunlight. These bacteria were doing what plants do on the surface, fixing carbon from inorganic sources into the organic molecules that living things are built from, but using chemical energy rather than light energy as their power source. Movil Cave, as it became known, was a sealed world, complete in itself, running on chemistry rather than light, preserved in isolation for 5 million years. An ecosystem that had been evolving in complete independence from the surface world since before our genus Homo had even emerged. Cave adaptations. The creatures that have evolved in permanent cave darkness share a set of adaptations that appear again and again across species from completely unrelated lineages in different parts of the world. It is one of the clearest examples in all of biology of what is called convergent evolution. Different lineages facing the same environmental challenges, arriving independently at the same solutions. Eyes become vestigial or disappear entirely. In a world with no light, eyes are not merely useless but actively costly. They require significant metabolic resources to develop and maintain, they are vulnerable to infection and injury, and they provide no benefit whatsoever. Natural selection eliminates them generation by generation, with the same relentless logic by which it would eliminate any expensive and useless structure. Cave fish descended from sighted surface ancestors have, over tens of thousands of generations, lost their eyes entirely, the eye sockets now covered by skin. Pigmentation disappears for the same reason. On the surface, skin and body color serve multiple functions. Protection from ultraviolet radiation, camouflage from predators, warning signals to other species, social signaling within species. In a cave with no light, none of these functions apply. The metabolic cost of producing pigment is spent on nothing. And so cave organisms trend toward white or translucent, the underlying biology visible through skin that has no reason to be opaque. Other senses expand to compensate. Cave fish develop lateral lines of extraordinary sensitivity, the mechanosensory organs that detect pressure changes and water movement in their surroundings, allowing them to navigate and hunt in complete darkness by feel alone. Cave spiders and insects develop elongated legs and antennae, maximizing the surface area available for tactile and chemical sensing. Some cave organisms can detect the chemical traces of prey or predators at concentrations so low they would be undetectable to any surface species. And metabolism slows. In an environment where food is scarce and unpredictable, energy conservation is everything. Cave organisms often live at a pace that would be unrecognizable by surface standards. The olm, a pale and eyeless cave salamander from the caves of Slovenia and the Adriatic coast, one of the few vertebrates specialized for cave life in Europe, may live for 100 years or more. It reaches sexual maturity at around 15 years of age. It may reproduce only once every decade, can survive without food for up to 10 years. A creature evolved for a world where patience is the only available strategy. Archives of deep time. Caves are among the most remarkable natural archives of deep time on Earth. The combination of stable temperature, constant humidity, isolation from weather and biological disturbance, and the preservative chemistry of calcium carbonate creates conditions in which things deposited in caves can be maintained in extraordinary condition for timescales that would destroy them in almost any surface environment. Ice Age mammals have been found in European caves in conditions of preservation that allow detailed reconstruction of their biology and behavior. Cave bear skeletons, their bones still articulated, lying exactly where the animal died tens of thousands of years ago. Pollen grains trapped in cave sediments record the vegetation history of regions across hundreds of thousands of years, allowing scientists to reconstruct in detail what the landscape looked like during the ice ages, what trees grew here before the glaciers came, what returned after they retreated. Speleothems, the collective name for cave formations including stalactites, stalagmites, and flowstone, have become one of the most important tools in paleoclimatology, the science of past climates. Because each layer of a speleothem was deposited at a specific moment in time, and because the chemistry of each layer reflects the temperature and rainfall of that moment, a stalactite is essentially a continuous climate record, written in calcite covering the period of its growth. Some speleothems have been growing for hundreds of thousands of years. They have given us some of our most detailed and precise records of how the Earth's climate has changed across multiple glacial cycles. The art of our ancestors. Perhaps the most extraordinary things preserved in caves are the works of human hands. In the Chauvet Cave in the Ardèche region of southern France, discovered in December 1994 by 3 speleologists following a faint draft of air from a previously unknown passage, some of the most astonishing art ever made by human beings was found on the walls. Horses, rendered with a sophisticated understanding of anatomy and movement that would not look out of place in a contemporary illustration. Rhinoceroses, their bulk conveyed with an economy of line that takes real skill to achieve. Lions caught midstalk, mammoths, bears, a panel of aurochs that seems to vibrate with barely contained energy. The Chauvet paintings are approximately 36,000 years old, twice as old as the more famous paintings at Lascaux, which had previously been considered among the oldest known art in the world. Made by people who were anatomically modern humans, biologically indistinguishable from us, living in a world of ice sheets and woolly mammoths and cave lions, going deep into the earth by torchlight to make images that express something we can feel the force of even now, even across 36 millennia of silence and darkness. What drew them into the dark? What drew them deep into caves that the bears and lions also used for shelter, carrying their torches and their ochre and their charcoal, to spend hours rendering animals on walls that almost no one would ever see? We do not know. We cannot know, not with certainty, but we can observe that they chose the deepest, most inaccessible parts of the caves for the most elaborate art, that they sometimes returned to the same walls over generations, that the art shows a care and an attention and a skill that speaks of something more than idle decoration. Perhaps the caves were sacred spaces, places of encounter with something beyond the ordinary world. Perhaps the flickering torchlight made the animals on the rough stone surfaces appear to move, creating something like animation, something like vision, something like magic. Perhaps going underground, into the darkness, into the belly of the earth, was itself a ritual act, a journey into another realm that had to be marked and responded to. What we know with certainty is this: 36,000 years ago, someone sat in the deep dark of a cave in what is now southern France, with a torch burning animal fat in one hand and a pigment-stained finger on the other hand. And they spent hours making something beautiful. And the beautiful thing they made is still there, in the dark, exactly where they left it, waiting. The underworld in human culture. In virtually every human culture that has existed near significant cave systems, Those caves have carried mythological and spiritual weight entirely disproportionate to their practical importance. Caves provided shelter, certainly. They provided water sometimes. But the significance they accumulated in human culture goes far beyond their utility. In Greek mythology, the underworld of Hades was accessed through caves and subterranean passages. The cave at Cape Matapan, on the southernmost tip of the Greek mainland, where a passage leading downward eventually meets the sea, was considered one of the entrances to the realm of the dead. The river Styx, which the dead had to cross to enter Hades, was said to flow through underground passages that emerged in the caves of certain sacred springs. In Mayan cosmology, the underworld was called Xibalba, a word meaning place of fear, and it was accessed through caves. The cave systems of the Yucatan Peninsula in Mexico, many of which are partially flooded and of extraordinary beauty, contain elaborate ritual deposits, offerings, and human remains that speak of sustained ceremonial use over thousands of years. The caves were not merely symbolic entrances to the underworld. They were the actual point of contact. In Hindu cosmology, the underworld is a vast complex of underground realms of increasing depth. In Norse mythology, the roots of the world tree Yggdrasil reach down into underground realms. In many indigenous Australian traditions, the ancestral beings of the Dreamtime moved through and under the land, and the places where they entered the earth are among the most sacred sites in the landscape. There is something psychologically apt about this universal association between caves and the underworld, between going underground and encountering something beyond the ordinary world. A cave does offer what the underworld is always said to offer: separation from the surface world and its familiar rhythms. A transition into something different, something governed by different laws. A place where time is not marked by the sun because the sun does not reach here, where temperature does not change with the seasons, where the ordinary sensory world is stripped away and replaced with something older and stranger. Going into a deep cave is, in a very literal sense, going into the earth, into the rock that the world is made of, into the darkness that preceded life and that will persist long after it, into a world that moves at geological pace and is entirely indifferent to the brief, hectic drama of surface existence. It is understandable that our ancestors found this experience to be among the most spiritually significant available to them. It is understandable that they marked it with the most elaborate art they knew how to make. The edge of the known. We have explored perhaps 40% of the cave systems that are thought to exist on Earth. The rest remain unknown, unmapped, unvisited. Some are inaccessible to human explorers because they are too small or too flooded or too deep, or in parts of the world where the resources for exploration have not yet been directed. Some may be entirely unknown, their entrances sealed by rockfall or buried under sediment, their existence unsuspected. Cave diving, the exploration of underwater cave systems, has opened worlds that no land-based explorer could reach, and what has been found has repeatedly surprised the scientists studying it. The blue holes of the Bahamas, submarine caves formed during the last ice age when sea levels were low enough that the Bahamas were dry land, contain layered ecosystems unlike anything on the surface, with distinct biological communities at different depths reflecting the different chemical environments of the layered water. The deepest cave in the world is currently Veryovkina Cave in Georgia, in the Caucasus Mountains, which reaches a depth of 2,212 meters. Exploring it requires weeks underground, roping down vertical shafts, swimming through flooded passages, camping on ledges in the dark. It is one of the most demanding physical and logistical challenges in exploration, and there are likely deeper caves still undiscovered, waiting in mountain ranges and limestone plateaus around the world. The exploration of caves is not finished. It has barely begun, and with each new system that is entered and mapped, each new species that is found living in the dark, each new formation that is encountered for the first time by human eyes, the world becomes, in some small but real way, larger than it was. A world beneath a world. There is a quality to cave exploration that other forms of exploration do not quite share. When you climb a mountain, you are moving through a world that is, in its essentials, the same world you started in. Weather, vegetation, altitude, but the same sky above, the same rules applying. When you dive in the ocean, the world changes dramatically, but there is still light, at least near the surface, still a connection to the atmosphere above, still a sense of something familiar not far away. A deep cave is different. A deep cave is genuinely another world. Not metaphorically, literally. A world without light, without weather, without seasons, without the rhythms that organize almost all surface life. A world where time is measured in the drip of water and the growth of stone, where the dominant sounds are water and silence, where the dominant quality of experience is the strange intimacy of complete darkness. People who spend time in deep caves often report a shift in their sense of time. Without daylight to anchor the circadian rhythm, the internal clock begins to drift. Hours feel like minutes or minutes feel like hours. The sense of urgency that structures most surface experience, the constant awareness of the time, of what needs to be done before the day ends, falls away. There is only the cave, only the next passage, the next chamber, the next discovery. And always, in the background, the awareness of how much remains unexplored. How many passages branch off from this one and have never been followed? How many chambers lie beyond the furthest point anyone has yet reached? How much of this world exists in complete and total darkness, waiting, as it has always waited, for the light that may never come? Into the earth. Let yourself go down now, not far, just a little way below the surface of things. Imagine the cool dark closing gently around you. Not a threatening dark, not the dark of something to fear, a still dark, patient dark, an ancient dark that has been here longer than anything living and will be here long after everything living is gone. Somewhere beneath the ground you are lying on right now, water is moving, slowly, imperceptibly, dissolving rock at a rate of millimeters per century, working patiently on a project that will not be finished for millions of years, opening cracks that will become passages, that will become chambers that will be found, one day, by creatures we cannot imagine yet. There may be caves down there already, chambers that no human has ever entered, that no light has ever touched, that are simply there in the dark, formed and forming, home to things adapted to the absence of everything we think of as necessary for life, home to pale, patient, ancient things going about their lives in the dark as their ancestors have done for millions of years. The world is deeper than we can see, fuller than we can imagine. There are worlds within it that operate on timescales and according to rules that have nothing to do with the world we live in. And there is something quietly comforting in that, if you let it be. The knowledge that beneath the anxieties and the urgencies of the surface world, something else is going on. Something that has been going on for a very long time, and that will continue for a very long time, regardless of what the surface world does. Let that thought settle over you now. Solid and still and older than anything. Let your breathing slow. You are safe. You are resting. And deep beneath you, in the patient dark, water is finding its way through stone, as it has always done. Good night.